Good morning. How are you? It's a post Christmas morning and happy holidays to everyone. Okay, now today we are going to recreate this 3 by 3 by 3 array that we did last time by using geometry nodes. So let's start. Okay, first we need a plane to host the geometry node, and let's name it as GeoNode 3D grid. Okay, I guess that's alright. Then let's go to the geometry nodes tab, create a new geometry node. I'll just call this G node 3D grid. Now we take out this geometry input and start our own. Let's start with a grid. Okay, so we have a 1 meter by 1 meter size grid with 3 vertices. As you can see here, if I turn on wireframe, 3 vertices, 1, 2, 3, 1, 2, 3. Okay, let's turn off the wireframe. Okay, so now we are going to add multiples of this grid so that we could go into 3D. Right now it's 2D, 3 by 3, and we need to go up on the Z axis. So we need a mesh line, and we are going to use endpoints. And for the count, we are just going to copy a similar settings as this one. So this 3 by 3 size, no, I mean 1 by 1, and the vertices 3 by 3. So we will copy this vertices so that we could just have one input. Let's put an integer here, so that's 3. Same for the y, and same for the count. And then, so this mesh line is going vertically at to 1 meter, same as this one, 1 meter, and then it will have 3 vertices. So that will be the one that will distribute these grids. So let's get an instance on points node using the points of the mesh line to instance the grids. There you go. So now what we need to do is realize instances so that all of these will be one thing, not two separate grid and mesh line. So meaning that all the vertices will be counted as one continuous set of indices. Okay, so now after realizing, we need to instance on points again so that we can distribute cubes on the points. Okay, that cube is too big because it's 1 meter, the same size as the grid. So maybe we could reduce it to maybe 0.35. Yeah. So now we have the 3D grid. Maybe 0.4. Okay. Now we have this 3D grid, and that's alright. But the last time we did was they had different materials, so let's just use our previous material, the random color material. So let's set the material and choose rand call, and here we go, same as last time. Now maybe we need to do some, since we are in geometry nodes, we can do a lot of manipulation here. Maybe we could add some variation to these cubes, like maybe rotate them on the z-axis randomly. Okay, so but since these are like all cubes, even if you rotate them in whichever axis, you won't see them because they're still cubes. So I've created a few cubes here in a collection. I call them beveled cubes. So let's turn this off for a while. So I've got one cube. First one is beveled on two corners, adjacent corners. Okay, second one is beveled on just one corner, and the third one is beveled on opposite corners. So when we rotate them on the z-axis, we would be able to see them because there's a bevel on each one. So let's go back to the 3D grid. Okay, now to assign the set of collection of bevel cubes, we just need to pull down that collection here, bevel cubes, like that, and replace the cube with these. Oops, what happened there? They're too big, and it seems like they like overlapped each other. So what we need to take, I guess, is separate children and pick instance. They're still too big because now it's 0.1. So the last one was, I think, was 0.25. Okay, now there you go. Still big though, so let's go down to 0.18, maybe 0.2. Okay, so now you can see that they're all distributed there, sort of like random, but you know how they adjust them, the rotation to, like, you see this set of guys, they look all the same. This all the same cubes. In this side, you want them to, like, maybe randomize them a bit, so we need to do something to the rotation. So from the rotation, we need to give a random value. Okay, what happened there? It has given a random value at different axes, so we need to give 0 on the x and y only, so that we can only rotate them on the z. So now it has randomly rotated on the z-axis by like 1 radian. They all rotate on the z-axis. If you can see it from here. Okay, so what, this looks quite chaotic. So what is probably more organized is to rotate them at 90-degree angles, right? So that they are still sort of random and yet, neat, sort of neat. Okay, so how do we do that? we will snap to 90-degree angles, not some random 7.5 radians. So let's look for snap. Use the vector math snap because the input to rotation here is vector. So now they've gone back to their original position because it's at 0. So what do we enter here? Is it 90 degrees? No, it didn't move. Oh, it doesn't move. Why is that? Well, it's because most, fields accept only radians. So if we want this to be 90, we should change this to pi over 2, right? Because, well, one full circle is 2 pi, half circle is pi, so 90 degrees should be pi over 2. And there you go, pi over 2. So, okay, you don't like this setup, this one is too flat, take the seed and change the seed. Okay, so now just move the seed and you can see they're all rotating at 90-degree snaps. Okay, so what if you want to slightly change their scale? You might want to, you might think that, no, it's just too uniform, maybe just change the scale a bit, randomly scale them on all axes, for example. So what we need to do is maybe just take another random value to the scale. There you go. And now they are randomly scaled on all axes. So the scaling is from minimum 0 to 1. What does that mean? I'm not sure. No, anyway, the 1 is the size, the original size, right? Because you have, for it to fit, we have put it at scale 0.2 for them to fit. So now if it goes to 1, it's gonna be huge again. So maybe we max out at 0.28 and minimum maybe 0.15. Okay, maybe 0.3, 0.32. Okay, so then now you have random scaling on all axes, right? Maybe you don't want the z-axis to be too, maybe you don't want it to be too big. 0.3, maybe maybe really 0.28 so that they don't clash each other. 0.25, yeah, so that they don't hit each other. Yep. Then maybe this one's too small, so well, let's use 0.18. Okay, so that's just a subtle scaling. So it looks like that. Let's turn off the wireframe. No, rendered view. Oh, it's too dark. I have a background here. Yeah. So there you go. See you next time.